I know I'm the only thing keeping you from lunch, so I promise not to go over time. Not going to spend too much time on my intro, but I'm from Portugal. I wrote a couple of Erlang and Elixir libraries. I occasionally do some open source stuff, and I'm just overall a big fan of games. Tabletop games, video games, doesn't really matter. And today we're going to be talking about LiveView and browser games. We're going to take a look at a particular genre of multiplayer browser games and look at parts of the implementation of one of those games. And as a bonus section in the end, we're going to see how some of these games evolved into mobile hit games. So as the motivation for my talk, I just wanted to show you this picture because I asked ChatGPT, make me a diagram of the architecture of a modern web application. This is what it gave me. You'll see that it doesn't seem to make that much sense, but I honestly can't fault it. This is how I feel modern web development feels like some days, like it's over-engineered. But maybe a better picture of it looks somewhat like this. So it's very common nowadays where you have two different teams working on two different code bases, like a backend team and a front-end team. And the code that they produce typically communicates through some sort of API. And in my 5 years of industry, that's pretty much all I've done. I've worked in the backend side, building out APIs. And I've only used Phoenix and Cowboy in my Erlang days to build out APIs and never to actually render out HTML to the clients. So I was meaning to learn about LiveView for the longest time, mainly because the architecture or the programming model is simpler in that you don't need to care about APIs. The code that you write is what the client sees. Sure, there's more happening behind the scenes, but the programming model is simpler. So going into this, my goal was, OK, let's learn LiveView, but I don't want to go through my 20th iteration of the blog example from HexDocs. So I wanted to find the project that I enjoyed, that I could keep coming back to. And it took me a long time to decide what it was, but I ended up deciding on a really old browser game that I used to play when I was growing up. So let's take a look at that game, and we need to go back in time about 20 years. And this was pretty much the golden age for browser games. At this time, there was lots of games being developed, multiplayer, single player, Flash, JavaScript. There was lots being done. But we're going to be taking a look at a specific subtype of browser games, which are multiplayer games that are pretty much web apps. And you'll see what I mean in a minute. Some of the notable titles in this category are listed here. So I'd just like to do, quickly raise your hands if you've at least played or know someone that played these games. Oh man, you're like the perfect audience. Great. Lots, maybe 50%. OK, cool. So these games had millions of players in hundreds of servers worldwide. We're going to take a look at some of them. So first one is called Gladiatus. I'm not sure if you can see this well in the back end, but basically this one is a more RPG type of game where you build out your team of gladiators and you go fight other players or monsters. But if you take a look at this is pretty much a web page. It's beautifully designed. If we take a look and zoom in on some of the components, you'll see, for example, on the left banner, this is just navigation. And in the center, we have something with tabs and panes, but for different gladiators. But this is all components of web applications. This game has no graphics, no CSS animations. It kind of predates much of that technology. So this is all something that theoretically you could build out with Phoenix, although I would probably be capable of doing it this nicely. Next example is Travian. So Travian was really cool because you started out with a village that had pretty much nothing on it, and as you sort of progressed through the game and entered later stages, you started to get your village kind of filled out. It was really fulfilling as a player to see your city kind of come to life like that. And a common mechanic of all these games is we have some sort of resource that's being produced 24/7. It doesn't matter if you're logged into the game, you're always producing resources somewhere in a structure or building of some sort. I'm going to zoom in in this component just so you see how it is. But basically, you have some production of resources, and you can play this game typically in one of two ways. Either you play the economic game, which is kind of an engine building kind of game, where every resource that you earn, you pretty much reinvest back into producing more resources. Of course, you have to build up some defenses, because the other way of playing the game is arguably more fun, but basically every resource that you earn, you train troops with it, and you take it to someone else's village for fun and profit. So next example is Icarium. So the theme for this one is ancient Greece. And what I wanted to show you here is player locations. So you have your own city, your own location, but this location is grouped up into a small cluster. And this cluster in this game is an island. So inside of your island, you're going to have your first contact with other players that can be hostile or friendly. But then you can kind of expand out into other islands, and the islands typically have a place in a 2x2 grid. So we can see in the left pane here that there's an X and Y coordinate, and this is how they map the islands. And the final example I'm going to show you is O-Game. So this is the one we're going to try to remake. This is one of the original titles in this category. I spent a lot of time playing this one. This is from 2002 in Germany. And you start out as a single planet with nothing on it, but like I said before, we changed the theme, but the underlying mechanic is the same. We have some mines that produce resources, and so you take those resources, and what most people did was they used it to build ships, which they then proceeded to move to other players' planets. So this is how it looked 20 years ago, and this is kind of how it started, and this is kind of how it is now. This is you can still play the original game. It's not a free game in many senses of the word today, but this screencast is actually from a clone of O-Game. And what I want to show, aside from how the interface looks, is there's a list of events that is happening here that have some sort of timers, and you'll see that the events are almost happening, and when they happen, when the timer reaches 0, nothing happens in the interface. So the game is predicated on the assumption that there's a full page reload, and that you as a player are supposed to navigate around and click different navigation elements to get updates of the game. And so the idea is, okay, let's try to recreate some of this, but where we can improve, we'll try to improve. Let's take a look at the data model for this game. Obviously, we have player accounts. The easiest way to quickly get through this is just imagine what you would get after running mix Phoenix gen auth. So you have your account set up, and those are what we use. And each player can have multiple planets. So planets are a core entity of the game. Every action that happens in the context of a planet, because that's where we have buildings, where we have units, resources, and all that. So planets are going to be central for how the game events take place. Additionally, there's also researches. This is how you unblock new stuff in the game. You research it on a planet, but once you do it, it's available globally. So this game means that when you play this game, what happens is you click some sort of element on the interface, and it generates, that event will complete sometime in the future. And so that will generate an event that happens with a future timestamp. And you can imagine all sorts of things, all sorts of ways that you could implement event processing for this game. But there's one factor that complicates things a lot, which is most actions can be canceled. So you might start building a structure and then cancel it to get your resources back. But you'll also see that the timing, the event timers are inserted pretty much in random order. So we're going to have a global table of events. And this is kind of a simplified way of how it could look. We have the planet ID, the timestamp, and some event information. And for example, if I'm in the interface and I click to upgrade one of the mines, what's going to happen is, like I said, it's going to add an event in there with some information about what is going to happen in the future and the time it will actually take place. So just to illustrate that events are not going to be processed in order, again, this is a multiplayer game, and one of the things that can happen is if you have lots of resources, another player can realize that and then send an attacking fleet to your planet. So if their ships are really fast, this means that, of course, it's going to happen. The attack is going to happen before the building completes, and then again, this is another thing that is really fun to do in this game. Is if you know what you're doing and you're online when you're getting attacked, if you have some fleet hiding behind the moon somewhere, you can again, if your ships are fast enough, do a defensive fleet transfer to your planet, and so what ends up happening is the attacking player thinks they're gonna have a nice profit from your resources, and then they get blown to smithereens. This is really fun to do as a defensive player because the blown ships generate resources on the orbit of your planet. You could recycle them. It's cool. So what this basically illustrates is that events have to lazily be processed. Because of the interleaving that can happen, the only way that you can do this right and not have concurrency issues is if you process events as they are kind of witnessed by players. And the way this happens is every time that you interact with some element of the game, you send a request to the server. That request is associated with a certain timestamp at server time, and what the server is going to do is it's going to process the events for your planets up until that specific timestamp. And then additionally, we have to send the results of whatever happened of the event processing to your inbox because, well, it can happen while you're offline. So events can be processed in two different ways. So you can imagine that in the same example that I was showing, if players keep interacting and both of them keep clicking, one of them is eventually going to click past this first timestamp, and so the first event is going to be processed just the first event is going to be processed, and then they keep interacting. The second one gets processed, the third one gets processed, but there's another option, another way that this can happen. So if everyone decides to just do their own actions and then log off for the day, the event just stay there on the table. But of course, you can have a background job that runs every now and again, and what it does, it just batch processes the events up until the current timestamp, so that you don't generate like huge lists of events that haven't been processed. This also means that events have to be processed pretty quickly. But yeah, so from what we've seen, it's all very based on full page reload. So when we try to do this using LiveView, the fact that we have a stateful connection to the server kind of unlocks real-time capabilities that just weren't there in the original game. So one of the examples that I have with my prototype right here is, like, in this interaction, I'm clicking to upgrade a mine. I'm getting the reply back to the server, and I can make it show up in a local build queue. So this no longer has that sort of full page reload effect. And I also know when that event finishes, I know exactly, the LiveView process knows exactly when to send a message to the server and say, okay, it's time to update the processes for this planet, for the current planet. This fixes some of the issues in that you can have some real-time elements for the events that you generate on your own entities, but like we saw, this is a war game, so other players can make offensive actions on your own planets. So LiveView doesn't specifically fix this, but what we can bring in to fix it is Phoenix PubSub. So it's super easy to imagine that upon mounting the LiveView, you would subscribe to the topics of all of your planet events. And so if there is an offensive action taken upon one of your planets, it just broadcasts a message to that topic. It's picked up by the LiveView while you're playing, and then in the front end code we can make it show up. this is just scratching the surface. The game has a lot of features that I didn't make that I didn't have the opportunity to change. This was my experience going into LiveView to learn it. I was only able to cover some of the core game mechanics, and it's actually uncanny how great of a fit this game is to some of Phoenix's features. I'm going to show you like a very, very quick demo. I'm going to ask you guys to bear with me while I do some screen mirroring magic here, and I'm gonna tab away to this prototype that I have running. Hopefully, let's see, screen mirroring. Okay, forgot to click it. This is okay. So this is how it looks. It doesn't look like the original game. I know it's a prototype, a work in progress, but I was able to recreate most of the entities in the game, so the buildings, the ships, and everything like that from the original game recreated into this version. Of course, I can't use the original game assets. These were generated using Gen AI. We can talk about it. It's not as cool as it was really laborious to do it. And in the Galaxy view, so for example, the current player is called ElixirConf, and then you can see in the example that I was showing in the slides where you had in Icarium the islands, the concept of that in O-game is a solar system. So the #1 slot is the closest to the sun, is the one where the planets are going to have the highest temperature. That changes some effects of the game. But then you can colonize the empty slots, and then if there are like this, the reason it doesn't show up anything here is because this is my own active planet. But if there are other players nearby, I can take action on them. So this is just a quick demo to show you what I have so far. This is I'm going to keep working on this. And back to the topic of multiplayer browser games. So of course, this happened, like this advent of these browser games, it happened like 20 years ago. The industry had lots of time to improve on the pitfalls of these games. More immersive experiences came out. So these games kind of lost popularity, but they still have very dedicated communities for pretty much each one of them. And this genre is actually not dead, even with even if it has become a niche, just because the same game can be found in newer titles in the mobile gaming industry. So one game that I wanted to talk about, you probably already know, it's Clash of Clans. This is a mobile game that it doesn't, like, it's graphic, it's not browser-based, it looks like it's very different, but if you strip away the visual part, the underlying game mechanics are pretty much the same. Every interaction that you have with the game is timer-based. But they fixed pretty much everything that was wrong with the original browser game. So the experience is more immersive. You can customize cosmetically how your base looks, how your locations look. So this would be a planet in O-game. And not only can you customize how it looks, when you actually level up your buildings, you have to place them individually on a 2x2 grid. What this enables is it's going to be different if you put your mines outwardly and then you get crashed from the outer perimeter than if you hide them behind walls. So this unlocks like a completely new dimension of strategy and tactics for the players to use. And the reason I'm showing you this is because in remaking the game, I don't necessarily have to make the same flawed game. There's the possibility of reusing some of the newer innovations into this new design. So there's a choice of whether I want to like recreate the game as it was like 20 years ago, or if I can fix at least some of the game's issues. So again, like I said, these games have mostly stayed the same. If you've played this game for like 20 years, you probably play it because you like it like it is. So it's hard for publishers to really develop something like completely significantly change the game because of that. And newer games just target the mobile market. So these ones have become rather niche. I know I haven't showed you a lot of code. I'm going to try to make up for it in the end. But I'm just going to share my experience using LiveView. So I used, I think, the most up-to-date version, 0.20. And I want to say that the experience was nice, but there's a small issue that was, so there's a lot of articles written online for LiveView, and then you might want to do something specific, and you search it online, someone has already done it, you think, great, I'm going to use that, and then what ends up happening is that code is for LiveView 0.12, 0.15, and you can either be lucky, and that's still the right way of doing things, or you can spend a bunch of hours trying to rework something that really should be done in a different way now. So in this sense, I think LiveView would benefit from a 1.0 release, just because it would clearly mark like what is still relevant and what isn't. And additionally, there's typically only one right way of doing stuff in LiveView, and as you kind of deviate from it, because you're not following the docs, you're doing your own project, you start. At least I started to get code smells whenever I tried to deviate from the path, and so that is really important to me, because I'd rather have the intuition that I'm not doing something idiomatically, look it up and then fix it, than to develop bad habits just because I was trying to make things work and not reading the docs. Finally, LiveView feels super easy to learn. Like, you can quickly get something up in the screen and it looks really great. It feels responsive, real time, but it's hard to master, especially if you want to optimize the payload that you're sending over the wire. It's really not as linear. There's a talk from last year's ElixirConf EU from Marlus Saraiva about this, about optimizing the payload. That talk was really great. Definitely recommend it. And so there's a lot to do here. What I'm showing is a prototype, a work in progress. I don't even want to spend too much time on the slide, but basically, there's still features that I need to flesh out, and then additionally to the core game features, we have like the admin tooling, being able to have multiple game servers in subdomains using a single auth server. That's not typically super easy to do with Phoenix. But what I'm doing today is basically switching flipping the switch on the repo. So I was building this on the side in a private repo, and I'm putting this out there. So if this kind of sparked your interest, I'm gonna keep building over there. And please just manage your expectations. This is something that can break at any time. I'm deploying this on Fly that has its own issues, but the main takeaways for today is how good of a benchmark I think these browser games are for our stacks. Like the features that I needed to pull in from Phoenix, and so I think they're a great benchmark for web frameworks in general, because it's not just what you can do with Phoenix, LiveView, Ecto, and whatever. It's how easy it is to do it. I very much believe that the process of adding these like real-time elements to the game would not be a fun experience in some other stacks that shall not be named, but yeah. And so if you can only take away something, like one thing from today's talk is pretty much none of these games have modern remasters. So if you played one of them and you think this could be a good opportunity to learn LiveView, then please go out and make one. This is a super fun experience. It's fulfilling in a sense to kind of recreate one of your childhood games. So I definitely recommend it. And yeah, that's what I had for you today. Thank you.
Thank you, Gonzalo. Do we have any questions?
Can you talk about the name that you chose for the game?
What, Galaxies, or just the name? 17 Galaxies is just my favorite name / Galaxies is what the game is about. It's really not that interesting of an answer, but it was Galaxies was taken in my GitHub repo, in my GitHub account. Yes.
Can you please do it responsive?
Responsive. That's a good question. I use Tailwind to build the interface, and so what it means is if you open the game in a browser, you get the navigation collapsed and you get a different view. So it's somewhat responsive. What I'm still working on is I've used the kind of classical view of the game where it's like you show the name of the building, for example, and then a long description, and that doesn't look as well on mobile, but it kind of fits. So it's somewhat responsive already, but yeah, it's one of the major pitfalls of these older games is they don't have mobile apps and they're not responsive. So yeah.
Thank you. Could you please tell a bit more? I mean, where do you update your state? Is it on the background on the server in the background, or is it through the client?
So most of the actions are taken by the LiveView process. So the LiveView process keeps a record of the timers that. So for example, if you're in the buildings page, you're going to be able to see your build queue. And so what happens is when you mount the LiveView, you fetch a bunch of events that are going to happen in the future. You use those to show a timer to the user, and then what happens is when those timers expire, we send from the LiveView. We make a call to a context function, like update the current state of the planet, if you're upgrading a building in this case, and then that updates the interface itself. I don't know if that answers the question.
Yeah, I mean, I understand that it's from the interface point of view, but what happens on the backend? Who is responsible for processing events or producing actual events which change the state? Because probably the planet has current state, and it's not clear for me.
Okay, so when you there are different types of events. So for example, let's say we're building we're upgrading our mines. So if there's nothing else going on, we're going to have to do additional steps, but it's always done from the backend. So there is a client request that says, please upgrade this item, and this is done so that you can't go in there because you can from a security standpoint, you can kind of assume or deduce what are the messages sent to the server, and you can kind of change it on the wire. So what the LiveView process does is like, there's a request from this player to update this building on this planet. And so it's then done on a separate process where it goes and does the prerequisites checks and deduces the resources from the planet and changes the state. But so they happen at different, across different boundaries. Clear now? Okay, hope so.
Maybe show the slide if you are productive.
Yes, yes. Make sure to show it with a disclaimer there. It's early stages. Thank you.
Hi, thank you for the presentation, Gonzalo. I just want to throw it out there. When you mentioned multiplayer browser games, I had a hope that you're going to talk something about like RuneScape. I guess there are some people here that probably know what I'm talking about. Are there any plans for something like that?
No, this old game was very much my passion growing up, and so like again, this is something as a project for me to keep my LiveView skills sharpened, and I'm going to continue on this one. But I end up exactly on that topic. Like if someone else grew up on a different game and you want to make it happen, the thing is, I'm not too great with graphics, and so this is the reason why I picked these is very specific, just because there are no animations, there's nothing other than code and basically assets, images. So
sure, yeah. I meant to throw it out there, but
yeah.
Now as a real question, I'm wondering how to since you're not using animation and graphics and no actual clicking and having to send to both of them, and you would have to broadcast all the movement to players, and that's you would still think that it would be usable to implement something, I wouldn't say as big as RuneScape, but or something related to player movement and sending all the movements through LiveView, or you would think that you would need something bigger?
That's a good question. I don't know explicitly how good like front-end graphic frameworks have become, but I think there are JavaScript libraries that can go pretty far. I think Photon.js is one of them. So I think you'd have to pretty much get to a point where I'm really not at right now with your JavaScript interop, but I think it would be possible to have to basically navigate to a route where you establish a connection with the backend and then switch over to the graphics element of it. I think that's kind of what LiveView, that's one of the main benefits of LiveView native. Once like ends up being mainstream, I think that's one of the things you're going to be able to do, because if you have the LiveView protocol to a Phoenix server, you can then implement a game. It's just going to be codes from your iOS app or whatever it is to interact with that. But to be honest, I don't really have experience with that. So, but it's an interesting side of it for sure.